Good day everyone. In this video, you will learn the Matlab code of Gauss Jacobi and Crout'S method. These two methods are used to solve system of linear equations in linear algebra. Considering the given system of algebraic equations, this can be written in the matrix equation form as AX is equal to B, wherein A is the coefficient matrix and B is the solution matrix, which is the one to be calculated. Like for example, we are finding the value of x, and the B is the constant matrix. Solving a system of linear equations comes with different methods. We can use direct method or indirect method. For direct method, we have Gauss elimination method, Gauss Jordan method, and the Crout'S method. And for indirect method, we have Gauss Jacobi method, Gauss Seidel method, and relaxation method. To furthermore discuss the functions of these two methods, Gauss Jacobi iteration method is a convergence of iteration depends upon the condition that the system must be diagonally dominant. For Crout'S method, we use the LU decomposition, in which a matrix is decomposed into lower triangular matrix, that is the L, and an upper triangular matrix, which is the U, and sometimes a permutation matrix. So what is diagonally dominant means? A matrix can be considered diagonally dominant if the absolute value of each diagonal element is at least as large as the sum of the absolute values of the remaining entries in the same row. For example number 1, the system of algebraic equations is diagonally dominant. For the example number 2, considering this system of equations, not every system of equations can be rearranged to have a diagonally coefficient matrix. LU decomposition is used in Crout'S method. Again, given a system of linear equations, we can write it in the matrix form AX is equal to B. So in this form, we have to suppose, or we may suppose, A is equal to LU, and we can substitute it in the given equation. So this will result to LU multiplied by X is equal to B. After that, we have to suppose UX is equal to Y. So the equation will become LY is equal to B. Now, looking at the formation of the lower and upper triangular matrix, matrix L is the lower matrix or the lower triangular matrix, while the matrix U is the upper triangular matrix. And we have here also the difference between the Crout'S and the Doolittle method. So for the Crout'S, we can observe that all the diagonal terms of the U matrix is 1. And for Doolittle scheme, all the diagonal terms of the L matrix is 1. So that is the small difference between the two. Matlab is a programming language that will be used in implementing these two methods. So Matlab is a proprietary multi-paradigm programming language and numeric computing environment developed by Mathworks. Matlab allows matrix manipulations, plotting of functions and data, implementations of algorithms, creation of user interfaces, and interfacing with programs written in other languages. So Matlab system consists of 5 main parts. We have Matlab language, Matlab working environment, handle graphics and mathematical function library, and application program interface. Given this equation, we will solve this using Gauss Jacobi iteration method and the Crout'S method. But make sure for the Gauss Jacobi, your equations are diagonally dominant. So the first part of the code is my name and the method that I used, Gauss Jacobi iteration method. The % sign with the green color is just a non-executable text in the body of the program, so it won't affect the whole code. For the dashboard, we have to define first the matrix A and matrix B. So N is the number or the size of the matrix. defining the matrix A and defining the matrix B. Just input the number of tolerance, and after that, this is the code for solving AX is equal to B, that we can check if it is square matrix or not. In case that we enter an equation that is not diagonally dominant, the code not diagonally dominant but it should be will appear. Then make an initial guess. This can be any number. You can change it into random numbers, zeros or ones. Still it will yield the same answer but different number of iterations. So D is for the diagonal element, and this is the code for the main loop, wherein we can compute also the error. So for the final input, just display the value of x and after how many iterations. So after inputting all the codes, we will run now the Gauss Jacobi method. Our initial guess is in the random numbers, and it will appear the size of the matrix. You'll input number 3, which is the V3 matrix, and then for the matrix A, you will enter all the values, all the corresponding values. We have 22, negative 13, 8, 8, 17, and then for matrix B, just enter all the values. Now we have, after 41 iterations, we find the value of x, which is 2, negative 5, and 2. You may also check the value of the diagonal elements, which is D, and N is for the size of the matrix, which is 3. We may also check the values of the matrix A and the matrix B. So for tolerance, 1 times 10 is to negative 6. Again, our initial guess for this code is random. We may change it into ones or zeros. So for Crout'S method, the first part is almost the same in the Gauss Jacobi. I input my name and the method that I used. Again, for the dashboard, define first the matrix A and the matrix B. For LU decomposition, initialize first the x and y with zeros, and input the code for the columns of L and U, and make sure to add 1 to have an increment. And then initialize the diagonal elements of the upper triangular matrix into 1. This code will display the value of lower and upper triangular matrix. And for the last input, this is for the formulas used to find x and y. So for the Crout'S method, you'll have to input again the size of the matrix, which is 3, the corresponding values or elements in the matrix A. We input same values or elements, the same as the Gauss Jacobi method. So for matrix B, again, we will enter those corresponding values. And here it is. On the command window, it will display the values of U, and for the L, as well as the Y, and for our X. We will notice that we yield with the same answer for Gauss Jacobi and Crout'S method. Checking all the code, it's working.